I'm going to try recording with my tablet here, and I thought I would just do an example of this problem to see if I could get you started. So here what we're going to do is fill in the information that is given in the problem. That's where you want to start. So we've got our table here. We're going to fill in the information from the problem. We see that resistor number 1 is 120 volts, 120 ohms, so we're going to write 120 in that box. We see that resistor 2 is 33. And resistor 3 is 47. And we see that the voltage on resistor 1, which is right here, which is 6 volts. Now, since that's V1, we're going to put that under E for voltage. It'd be 6 volts. So we'll put it right there. So we're going to go up here, get a pen. We're going to put in 6 volts right there. Now, that's all the information that we have, but we can solve the rest of this problem. You're going to remember that all of the resistors add, so that the total resistance right here is the sum of the resistors above it. So we're going to add those up over here on the calculator. So we're going to do 120 plus 33 plus 47, and that gives us 200 ohms. And so we're going to write 200 ohms right there in that box. Okay? Now, since we don't have anything over here that we can add up, and we don't have anything in the middle column yet, we've got to start looking for a row that has 2 pieces of information, which that's going to be row number 1 right there. We've got E and we've got R, and you're going to remember that I is equal to E divided by R. Just getting that off the Ohm's law wheel. So we come over here to the calculator, and that is 6 divided by 120. Oops. 120, and that works out to be 0.05. Now, you've got to be careful here. That is 0.05 amps. But look at this box. It wants your answer in milliamps. So you remember to convert from amps to milliamps. You're going to move the decimal 3 places to the right. So here's the decimal, the 0 and the 5, and we want to go 3 places. 1, 2, and we're going to have to add that 0 to be able to get the decimal over there. And so the number becomes 50 because we moved the decimal, and this gets a 50 milliamps. Now you also know that current is the same in a series circuit, so since you've got that 50, you're going to put it in all the boxes. All right, now, knowing that all the currents are 50 milliamps and knowing all the resistors, it's simply a multiplication problem to find E, because we know E is equal to I times R. So 50 milliamps, and you can either enter that on the calculator as 0.05 as it is here, or you can enter 50 exponent -3 times 33, and that's going to get us to 1.65. And then you're going to say 50 milliamps times 47, 50 exponent -3 times 47, and that gets you to 2.35. And then finally, we want this voltage here. Now there's 2 ways to get this number. This number is the sum of these numbers up here because of Kirchhoff's voltage law, which says these add up to the total, or you can simply use Ohm's law here and multiply. And I think it's faster to multiply, so we'll do that. 50 exponent -3 times 200, and that works out to be something wrong. -550, that's not right. What did I do wrong? E is equal to I times R. 50 exponent -3 times 200. 10, that's better. I don't know what I did. 10 volts. And that's your answer. And you can check that. 6, 7, 8, 9, and then the 35 and the 65 is another 1. So there's 10 volts. And that's the way that you do the problem. And so try that, and that works on all of them, and see if that helps you get started. And if not, just send me an email, and I'll be glad to maybe give you some more examples. Talk to you later. Bye.